Hello guys, once again welcome to our YouTube channel Edu Hub, and as you know, this part 2 of Python programming beginners to experts. So without wasting time, let's get started, and don't forget to like our video and share to your friends and family members. Python programming beginners to expert part 2.
So in this tutorial, I'll be talking about iter tools in Python. So iter tools, actually it's a module, it's a collection of tools for handling iterators. So they are actually data types and can be used with for loops. So iter tools also has some advanced tools. The most common iter tool is actually a list. So let's discuss some tools here. The first one is actually products. So in order to use products, we can say from iter tools. This is actually inbuilt, so you don't have to install anything. We can say import product. Yep. And now I can say, now I can actually declare two lists, maybe 1 2, and a second list with items 3 and 4. So now we can say product is equal to product of A, comma B. Now if I just print the products, so what this will do is actually calculate all the possible orders, or all the possible orders for this particular list. So if I just run this program, okay, this is actually an iteration tool object. So in order to properly print it, we need to convert it into a list. So let's say list here, and now if I run the program, we can see that this products tools has been printed. So now we can actually specify some additional parameters here. So for example, we have a repeat parameter and we can set it to 2. So now we are allowing it to do repetition. So I'll show you what I mean here. So if I run the program, okay, this list is too large, let's just shorten it, let's remove some elements, and if I run this, okay, we can see that now repetitions are allowed. So okay, so now since repetitions are allowed, it is actually repeating here. So it's actually repeating, so 1 3 and 1 3, and then 1 3 and 2 3, and then 2 3 and 1 3. So it's actually getting all the possible orders from here. So now let's take a look at combinations. So combinations, so we have to import combinations. So from iter tools, we'll import combinations, and now what we'll do is we'll declare a list here with some items inside, and now let's say comp is equal to combinations of A, and we also have to specify the length here. So we have to specify the length here. So let's say 2. So this is actually going to be the length of the outputted list. So now if I just print list of comb, and if I just run this program, you can see that we get items, we get some list with some items inside. So if we just change this to 3, we change the length to 3, okay, the length is also changed to 3. So yeah, so this will actually make all the possible combinations for this particular list. So another iter tool we are going to take a look at is the accumulate tool. So yeah, so for that we have to import from iter tools. Let's import accumulate. So yeah, this will actually print an accumulated sum actually. So I'll show you what I mean by here. So let me declare a list here with some items 1 2 3 4 5, and then we'll say ACC is equal to accumulate of A. Now let me just print both A and accumulated A. So if I just run the program, I actually have to specify list of A here. So this is now an iter object, so I have to say list, and if I run the program, you can see that it has actually printed out an accumulated sum. So here it is 1, then 1 plus 2 is actually 3, and 3 plus 3 is actually 6, and 6 plus 4 is actually 10, and 10 plus 5 is 15. So we can also, this is by default, this is actually addition. We can change it if we want. So I have to import operators for that, and then to actually say, and I have to specify another value here called function is equal to operator dot mul. Yes, this one. So we don't need braces here. And now if I just run the program, so we can see that we have actually got the results here. So here 1 is 1, so 1 into 2 is actually 2, and 2 into 3 is actually 6, and 6 into 4 is actually 24, and 24 into 5 is actually 120. So that is how this accumulated iter tool works. So the final iter tools I would like to discuss here is the infinite iter tool. So this will actually, as the name suggests, this will actually be executed until we stop it or we have a condition to stop it. So to use this, we can say from iter tools, we have to import we have three iter functions, cycle, or we have the count first, count, and then we have the cycle one, and then we have one more called repeat. So these are all infinite iterators or infinite iteration functions. So let's see how count works first. So say for an example, I'll use a for I in count of 10, and I print I here. So if I run this program starting from 1 or starting from 10, it will actually print infinitely. It will print without any stopping, or it will actually, if I just stop this program, okay, I've stopped it because it is actually printing out a lot of numbers. So what this count function will do is, here it is actually taking 10 as a parameter, so it will actually start from 10 and it will actually add 1, and it will actually continue printing elements infinitely until we stop it. So I can maybe say if I is equal to 15, then we have to maybe break out. If I run the program, yeah, you can see that 10 11 12, and at the end at 15 we actually broke out of the loop and the program has stopped. And if I don't specify this condition here, it will actually continue printing infinitely. So that's the count method. And now we also have the cycle method. So I have a list here maybe called 1 2 3, and we have actually set its name to A. So if I say for I in cycle of A, and if I just print I just run the program, what it will do is that it will actually keep on printing this these three numbers in a cycle. So it will start with 1 2 and 3, and then it will actually cycle back, and it will again start with 1 2 and 3, and it will actually print infinitely until we actually stop it, or we have some condition to stop it. So the final method we have is the repeat method. So for example, I say for I in repeat, and I specify 1 here, and if I print I, and if I run this program, this will actually keep on printing I here until we stop it, or we have some condition to stop it. So we can also specify how many times we actually want to print it here. So here I have specified 10, so it will actually print 1 for 10 times. You can see that it has actually printed it 10 times. So this is the repeat function. So this is all about iteration tools in Python. So hello guys, so in this tutorial I'll be talking about lambda functions in Python. So lambda is actually a very small anonymous one line function, and it is defined without a name. So it is actually comparatively a very small function, usually one line. So the syntax is actually lambda, the keyword lambda, and then the arguments, and then an expression. Let's show you an example. So uh, I'll declare a function, or I'll declare a name or a variable here called add10, and I'll say lambda x plus 10. So this is a small lambda function that can actually add 10 with a given number. So here the argument is x, and so let's run this function. So I can say print add 10 of, and we have to specify x here, so I'll say 5 here, and let's print this. If I run the program, you can see that I get 15 here. So yeah, 5 plus 10 is actually is equal to 15. So this is a lambda function, it's only one line, but a normal function similar to this would be, so I'll say diff add, I can say just add here, and I'll say, so I have to specify the arguments inside this, and then I'll have to say x is equal to x plus 10, and I just have to return x. So now if I say print add of 5, and if I run the program, you can see both of them are printing out similar results. So what do we use it for? So actually lambda functions are very simple, and it is used when we only want it maybe once in a code, not once in our entire program, or it is also used to specify as an argument to other functions such as filter, sorted, and reduce. So we'll be discussing about this filter, sorted, and reduce functions. But before that, if you just want to change this addition to multiplication, let's see what we can do. So to change this, you simply have to say, we have to declare two variables here. This is actually going to be a function that can multiply two numbers. So I'll just change sum of it, and then I have to say x multiplied by y. So if I just remove this function, we don't need this or this, and now we have to specify two arguments inside. So I'll say 5 and 10, and if I run the program, we can see that 5 into 10, 50 has been printed. So yeah, we can actually do multiplication as well. So now let's take a look at the three functions that I mentioned before, that is the sorted, filter, and the reduce function. So let's discuss about the sorted functions. So sorted function, as the name suggests, it is actually to sort a list. We can even actually specify a set of rules by which we actually want to sort this list. So let's declare a variable here, or a list here. I'll call it point 2D. So we'll have some 2D points, two-dimensional x and y axis points here. So we are going to declare some tuples inside this list, 1 2 15 1. This can be whatever you want. This is actually just random. 5 1, by -1, then 4. So now to simply sort this, you can actually say, we can actually declare a variable called s, and we can say sorted, and then we say point 2d. And now if I just print this s variable, and if I just run the program, you can see that this thing has been sorted. So now it is actually sorted based on the x-axis. So 1 comes first and then 5. So yeah, it is actually sorted based on the x-axis. The smaller x-axis come first and the larger x-axis go behind. So yeah, that is how we actually sort it by default. But you can also specify some rules to sort it using the lambda function. So you have to specify another argument here called key, and now inside this we should have a lambda function. Let's say lambda x of 1. So now what we are saying here is we just have to sort it by x of 1. The 1 here is the index, so we just need to sort it on the y-axis or the y-index or the second index. So we say 1 here. So now if I run the program, this will actually be sorted on the basis of the y-axis. Now you can do the same thing using a normal function. So I can say maybe define sort by y, and we can actually specify an argument. The x here is just a variable, it can be whatever you want. So we say return x of 1. So yeah, so now we have to specify the key here, so we can specify the function. So I'll say sort by y without the braces. Now if I just run the program, you can see that it has also been sorted the same way. So we can use the lambda functions instead of this, because we actually have to reduce the number of codes we write. So lambda function can do this with a single line, so we can actually save or reduce the complexity of the code. So here we can also sort by the sum of both of this. So for example, this is 3 here, this is 16 here, so we can actually sort by that method as well using the lambda. So we can actually remove this function, so we just remove this as well. So now we have to write a lambda function to actually sort it on the basis of this addition values, or by adding these two. So we say key is equal to lambda of x and x of 0 plus x of 1. So yeah, it is actually sorting using the sorted method, and this is just the rule. These are just the rules on how to actually sort it. So we say add both of them and sort it that way. So the smaller elements come first. So if I just run the program, we can see this has come first because this is probably the smallest, because 1 plus 2 is 3 and everything else looks greater than that. So this is about the sorted method in Python. So I just wanted to show you how to use lambda with sorted. So now we also have to take a look at the map function. So map is actually used to apply a function to a sequence of numbers or a group of numbers. So for example, I have a list here with some items or with some numbers inside. So let me declare another variable here and apply map. So let me say map, and we have to declare the function that we have to actually apply to this entire list. So we'll say lambda x. So we are declaring a function that is actually going to multiply 2 with every item in this list. So I'll say x multiplied by 2, and this is actually the item or the item that we actually want to apply this function to. So now if I just print b, this will be a map object. For example, if I run this is actually a map object. So to actually get the correct output, we have to convert it into a list. So I'll say list. Now if I print it, we can see that 2 has been multiplied with every element or each and every element inside this thing. So this is how the map function works. So we can also do this in a similar way using list comprehension. So we have to say C is equal to X multiplied by 2 for X in A. So A is the list here. So now if I print C, and if I print this as well, now if I run the program, you can see both of them have the same result. So you can do this similarly using list comprehension method. This is the most preferred method, but you have to know how to actually use the map function and lambda inside it. So that's about map function. Now let's take a look at the filter function in Python. Now let's discuss about the filter function in Python. So filter function is actually used to filter a list or a sequence of numbers based on a function. So I have a list here with some numbers. So now let me say b is equal to filter lambda x. So we are going to filter all the even numbers inside this. So we'll say x modulus q should be equal to 0, and we are going to pass the function that we need to apply this to. Now if I print b out and if I run the program, you can see this is actually a filter object. We have to actually convert this into a list, so we'll have to say list. Now if I run this, we get filtered out all the even numbers. So this is how we actually filter things out using Python. So the same thing can be achieved using list comprehension as well. So we can say C is equal to X for X in A if X modulus 2 is equal to 0. Now if I print both A, B and C, and if I run the program, you can see both of them are outputting the same result. The same thing can actually be achieved with list comprehension, but we are here to take a look at the filter method. This is how we filter a sequence of number using a function, a lambda function inside. So now let's take a look at the reduce method. So in this tutorial, I'm going to be taking a look at the reduce function in Python. So reduce function takes in a function and a sequence, and it repeatedly applies the function to the elements, and it returns a single value. So say I have a list here like a 1 2 3 and 4. Let's declare a variable. Okay, let's declare a variable called product, prod, short form for product, and we'll say reduce of lambda x. So now we have to import reduce here. So we have to say from function tool import reduce, and this will actually import reduce. We have to import it. Now let's calculate the product. We'll say lambda of x and y. We'll have to calculate the product of two numbers, and we'll say x asterisk of y, and we'll have to pass the list, which is a in this case. So if I just print the product out and if I run the program, we can see this has actually printed the product. So we'll say 1 into 2 is 2, 2 into 3 is 6, and 6 into 4 is actually 24, and it has actually printed out the product of this list. So that's everything about lambda functions in Python. So we have additionally learned about reduce method, map method, and filter method. So that's it about lambda functions. So in this tutorial, we'll be talking about error handling in Python. So we need to actually know how to actually handle errors. Okay, there are mainly two types of errors: syntax errors and exception. So syntax errors occur when you actually type the wrong syntax. So the predefined keywords and the predefined things in Python, they all have syntaxes. So for example, print print should have this print statement followed by this open and close braces, and only inside quotes only you can actually type something. So if you, for example, add an extra braces here, this is actually a syntax error. You can see that is actually a syntax error because we added an extra braces here. So that is not possible because we have to follow the Python syntax here. So these are called syntax errors when you sometimes add an extra colon or an extra braces and Python raises a syntax error. Syntax errors are much easier to solve because you know the Python syntax and you can easily solve them. The next type of errors are exceptions. So for example, I say a is equal to 5 plus a string here, maybe hello, and if I try to print a, we'll get an error saying type error unsupported operand. We cannot add an indent string together, so we get a type error here. So that is the type error. We get this when we try to add an indenter for an example. So we also have other errors. For example, I'll say import module or something, some module that doesn't exist, and if I run the program you can see another error saying module not found error. This is actually an exception saying that no such module exists. So we also have other errors like name error. For example, I'll say a is equal to b or a is equal to 1, and I'll say b is equal to c. Now if I just simply run this program, we get a name error actually saying that c is not defined, so we have not defined what c is here, so it's actually name error. And then we have a lot of exceptions. So another thing I would like to show you is the file not found error. For example, I'll open a file here, so I'll say with open, and let's try to open a file that doesn't exist. I'll say no file dot text. Actually this is a file name and I'm sure that it doesn't exist, and we have to specify read mode here, and I'll say as file. So now, and if I say pass here, and if I just run this program, you'll get the file not found error because no because no such file or directory exists, so it cannot be opened. Then we have the value error. So to show the value error, let me just declare a list here with a 1, 2 and 3, and now if I say print a of 4, I'll get an index error. So because it is out of range, so here we only have 0, 1 and 2. So two indexes, two elements is 3 elements in total. So here I'm trying to access the fifth element of index 4, and that doesn't really exist, so we get an index error. Now if I just try to remove an element or add an element, I mean if I try to remove an element that doesn't exist, I get another error called value error because it doesn't exist. So these are all different types of exceptions, uh, and one final exception that I would like to show you is something inside a dictionary. So we'll say dictionary is equal to, and I'll just create a sample dictionary. I'll say name is Jack. So now if I say print dictionary of age, we have actually seen this error before. This is actually a key error when you try to access an item inside a dictionary that doesn't exist. So it gives out a key error. So now we can actually raise our own error, I mean our own exceptions. So for example, say I have a variable with value 10. I can manually actually raise an exception here. If I say if a is greater than, or if a is less than 15, then I can use the raise keyword to actually raise a manual error. So I can say raise exception, and inside the braces we have to specify the error message that we have to print. So here simply we'll say error uh, value less than 15. So yeah, now if I just run the program, we get an exception here with the message that we actually printed here. Error value is less than 50. So now if I just change this to maybe 17 and rerun the program, now if I rerun the program, you can see that that exception is removed. So if I change this again and run this, we get the same error. This is actually this is the exception that we declared here. So we can also use the assert keyword here. So if I just remove this and I'll say assert, and assert, and after that inside braces you have to say 10 or a should be greater than 15. So now if I run this program, you'll get an assertion error. We are actually saying, or we are actually forcing and saying that a should be greater than 15, but it is not. So we get an assertion error here. Okay, so now we actually saw different types of errors and exceptions that we can actually encounter in a real program. So now let's see how to actually handle these errors, or how to actually what if we actually meet with such an error, the program actually breaks and the execution of the code stops. So that is where error handling comes into play. We need to understand how to actually handle these errors. So for this we use the try except block. You might have seen this thing. So we'll say try, so we'll say a is equal to 5 divided by 0. So normally this would actually raise an error here. So this would raise a 0 division error, because actually we cannot divide a number by 0. So yeah, this is one such exception, just like the other exceptions we discussed before. So this is the 0 division error. So now what we are going to do is we'll actually put this inside a try block. So I'll say try, and now we'll just put this under this to make it correct to the syntax. So now we'll say except. So we need an except block. Now we'll say except we'll print, we can print something went wrong. So yeah, so what we are actually doing here is we are actually expecting an error here. We think that this thing can actually fail sometimes, or in this case this actually will fail. So sometimes a program may fail, or some functionality, or some part of the program may fail. So in such cases we use try and except blocks. So now if I just run this program, you can see that it's actually going to the except block. Now if I just change this to 1, and if I print a, now if I run this program, you can see that the except block didn't get executed because the try block was not a failure. It succeeded and no error was printed out. So if I just change it back to 0, now if I run the program, it is actually the 0 division error that is happening, but the execution did not stop because we use the try except block. Now we can actually execute things here. So we can say something, I don't know, maybe something and if I run this, we can see that the execution did not stop. Even though it was actually an error, it continued executing the rest of the program without actually minding that thing inside. So this is why we can actually use try except block. So if I just remove this except and try, and if you only actually have this code, so say I only have this code here, and now if I try to run this, this will actually be a zero division error, and whatever I execute after this, so if I say print something, and that will actually not get executed because the program execution is stopping here. That is why we can actually use try and execute uh, or try and accept here. So now we can also accept a particular type of error. For example, here we will be getting zero division error, right? So we can only check for that particular error. So I'll say accept zero division error. So here only if the zero division error occurs, it will actually go to this block. So we are expecting a zero division error here. So if I run this program, you can see that something went wrong, or we can say here zero division error occurred, zero division or error occurred, or whatever you want. And if I run this, you can see that this code is still being executed. So we are actually expecting a particular error here. So that is what is happening here. So instead of printing our own custom messages, we can actually print what the error actually is. So I'll say accept zero division error as E, short form for error. So E here is just a variable, so I can just print E. So this will actually print the real error message, but the program will not stop. So it'll say division by zero. This is actually the message by the system. So you can actually add multiple exceptions here. So say for an example, I have a B variable here, and I am trying to add a number and a string. This will probably be a type error if I'm correct. So I'll say except type error. Yes, type error as T. This is another variable. So we'll print T. So yeah, let me just remove that error. Now if I run the program, you can see that we are getting the type error message, but the program execution has not stopped because this final code has been executed. So yeah, we can actually catch different errors, or we can use multiple except statement to catch different errors here. So we can also use an else statement here. So this means if everything goes well, just print me. So we'll say everything is fine. So now just remove this, and we'll add a 1 plus 1 here. And if I run this program, we get everything is fine. This means that none of the exceptions occurred, or no error occurred, and everything is fine. So we also have a finally statement. So this is a finally statement. So we also have a finally class. So this will get executed no matter whatever error you run into. So this is usually used for cleaning up actions. So finally will get executed no matter, even if an error occurs. So if I say print cleaning up or clean up or whatever you want, and I'm just removing this type error from here. So let's add a string with an n here. So this will naturally run into an error. So let's see what happens. So yeah, the finally has been executed. The program broke, or the program actually stopped, and this final something statement didn't get executed. The program actually broke here, but in this line it broke, but it still was able to print this cleanup. So even if an error occurs, you want to do something, then we have this finally statement. So that is why it is used for. So we can also create our own error messages or our own custom errors. So for that we have to say class and the name of the error you wish to create. So for example, I am actually declaring a variable here called a is equal to 100. So now I'll say if a is greater than, or if a is greater than 500, then it should raise an error. So for that I'm declaring an error here. So I'll say class value. So I have a variable here and a is equal to 100. So now I'll create an error class, say class value to high error. So yeah, so this is a value to error and it takes an argument inside called exception, the exception message that we should actually print along with the error. So and it'll say pass, and now you have created your own custom exception method. So now I'll say if a is less than, or if a is greater than 50, then it should raise the value to high error with a message inside called value to high. So now if I just run this program, yeah, it's actually raising the error called value too high with the value, with the statement that we said inside. So now let's catch it with the try exit block. So we'll say try, and now let's push it inside. Now we'll say except value to high error. We just print value too high. So now if I run this program, we get the message saying value too high. So this is how we can actually create custom errors. So you can create custom error messages for yourself using this method. So that's it about error handling in Python. So in this tutorial, I'll be talking about the logging module in Python. So logging module is actually used to log information related to your program or software. This is actually not necessary, and this is perhaps the least used thing. You don't use it everywhere actually, but you may actually need it if you are building a complex software with lots of classes and functions. You may have to use the logging module. To some extent we all do logging, but we do that using the print statement. So for example, we actually say print it started working, or something started working, or some server has started, or something has started, and we actually log, or we actually print if something goes wrong. We'll actually say that didn't work properly, this didn't work properly. We actually use the print statement for doing such things normally, but you can actually do this with the logging module as well. So but if you are actually building a complex software with actually lots of users, you may actually want to log the information, because if something goes wrong, for example, if your program is crashing, then you can actually check the logs and see what's happening and then fix it accordingly. So that is the use case for logging. It's not something we use every day, but if you want to use it, it's actually really good and can be used. So before actually talking about the logging module itself, we have to talk about the different logging levels. So we can simply use logging by saying import logging, and we are ready to actually use the logging module. So import logging. So you can simply use the logging module now. But before actually using it, we have to actually say we have to actually talk a little bit about different logging levels. So for example, we have different levels like debug, which is actually for debugging the program. We have info. It actually helps us providing the info about the software. For example, something started working, something has stopped working, such things, basic infos. Now we also have warning. So this is actually something that can go wrong in the future if it is not looked into. So we may need to actually look into it and see what is happening, what is causing the warning, and maybe fix it, or else it can be a problem in the future. We also have the error. which is self-explanatory. Something has gone wrong, but it has not stopped the program completely, or the program is in not a state where it has stopped working completely, but something has gone wrong and we may need to look into it. And we also have critical. So this is actually the most severe issue you can actually get. So something has stopped the program, or something has stopped working, and the entire program may be at risk, and the entire program may not work properly from now on. So this is actually the most severe issue you can encounter. So these are all the 5 levels of logging. Now you can simply log information by actually you can simply log information by actually saying logging dot log, and you can actually log information. So I can say logging dot, you have to specify the level here, so I'll say info for example, and then we actually say this is an info. So now this is actually the logging model. Now if you just run this program, let's just run it. You can see that nothing has been printed because we have not set the log level yet, because by default small levels like this info will not be printed. Small levels like debug info will not be printed because they are lower level issues and they are not necessary to be printed out. So to actually manually configure this, we have to say logging dot basic config, and we'll have to set the level here. We'll have to say level is equal to logging dot info. Now if we just run the program, yeah, we have actually the info printed. So now what will happen is everything below info will be printed. So info, warning, error, critical, all will be logged, but debug will not be logged. So if we want to log debug as well, we'll have to say debug. Now everything will be logged. Now even if we just run this, info is getting logged. If I change this to debug, that will also be logged. You can see that it is debug here. It has also been logged. You can do this. Okay, now there are some other ways to actually log this as well. Now if we want, we can actually log all the levels. So for example, I can just log everything, all the 5 levels. I can say maybe I can change the second one to info, the third one to warning, fourth one to error, and fifth one to critical. Now if you run this, you can see that everything has been logged here. So this is how we actually log all the levels. So there are other ways to log as well. We can use some other methods. So I can actually say, for example, okay, so if I run this, you can see that everything has been logged and the name for the logger is root. Here it is root, and we can actually change that as well. We can actually say logger is equal to logging dot get logger, and we specify an logger name here. I'll say test logger, and instead of doing this, we can actually say we don't need this anymore. We can say logger dot log, and we can actually set the level and everything here. uh, so instead of log, we have to actually say logger dot debug, and we can specify our message here. So we can actually say debug. We can also do the same with others as well. So let's copy paste this 5 times and log all the levels. So we have debug info, we have warning, we have error, and critical. So this is everything. So Yeah, if I run this, you can see that our logger name has changed to test logger. It was root before, now it has been changed to test logger, and you can do this as well. We can also log into a file, because in the real world we just don't print it in the terminal, we log into log files and then later we actually take a look at them. So log files have a .log extension at the end. So to actually log our information into the file, we can actually say we can actually come here and we'll say file handler is equal to logging dot file handler, and now we have to specify the name for the file. So we'll just specify a normal file name here, logfile.log, for now, because we shouldn't actually name our file like this. We should actually name it ideally, or actually we'll just look into it later. For now we are just calling it logfile.log, and then we'll have to set the level for logging. So we need to actually set a level in which we want to actually log into the file. We don't want every information in the file, that will be confusing. So we'll say dot set level, and we'll set the level to logging dot warning. So we'll take only actually we'll say warning. Okay, so we are only taking everything from warning. So warning, error and critical, info and debug are not needed for now. So now we have everything. We just need to say one more thing to actually finish this. We'll say file handler, sorry, we'll have to say logger dot add handler, and we have to actually add, we have to pass in the file handler here, and that should be enough. So here I'm actually logging everything, including debug info, but in the file we will only have the everything after warning. So we'll only have warning, error and critical, we won't have this. So let's just run it and see what happens. So as expected, we are actually getting all the log levels in our terminal. So if I just take a look at the file, we can see that I haven't actually changed the name here. So let's just change the name. I'll say info, and we'll say warning, we'll say error, and we'll say critical. And let's see, let's just remove this, we don't need this. And if I run this again, everything is printed here. So if we just look at here, we only have the warning, error and critical. We don't have the debug and info here, because we have set it to log only everything after warning. So higher level after warning, error and critical in this case. Okay, so now let's see how to name our file efficiently. So here we have a file named logfile.log. This is not really good. So what will happen here is we'll have a big log file with a lot of information. We may not know when it actually happened. So to actually log it into a file with the date name. So the file name should be according to the day. So to actually do that, we don't need this. We need to actually say, we need to actually import datetime. We'll actually say today is equal to datetime dot today, and this will actually get the list. Now we have to format it a little bit. We'll say file name is equal to, and we'll inside an f string we'll actually say, we have to format it a little bit. So we actually have to say today dot month, and we have to put a 0 to t here. So this is just to ensure that if the date is 1, it will actually log in as 01. That is why this is actually used. So now we'll actually have to specify day, and we'll actually say today day dot day, yeah, day, and we'll do the same thing 02D, and we'll say today dot year, yeah, and we don't need that formatting here, and at the end we'll actually say dot log, because it's a log file. We need to say dot log at the end, and we have something unwanted imported here. We don't need this. Okay, so now that's over. Now, but now actually we need to pass this file name here inside the file handler. We have to say file name. That should be enough. If we rerun the program, we'll have a new file with today's date. So yeah, I have one here. If you just look at here, it has been logged, and the date, day, and month, and the year has been actually is the log file name. So this is actually really good now. Now, if you just look into this file, it's just simply saying error, warning, critical. We just don't know a lot of information here. We just know something happened, some error, some critical things happened, but we just don't know when it happened, when exactly it happened. So we need to actually log such information as well. So to actually format this message a little bit, we have to come down here, and we'll have to add a formatter. So let's just go here, and let me just remove this. Okay, so now here let's say formatter is equal to, and we'll actually say logging dot formatter, and we need to actually specify something here. I actually took this from the documentation, so if you just check the logger documentation, you'll find how to do this. So this first one is just logging the time. Actually, this first one, this # ask time, this format is actually logging the time when this actually error or critical or whatever actually took place, and this level name is actually specifying the level or the logging level. So whether it is error or whether it is critical, whether it is a warning or whatever, and the final one is the message. This is actually printing, or this is actually adding the message. So okay, after doing this, we have to actually say file handler dot set formatter, and we'll have to pass in the formatter variable. Now we are actually done. This is actually logging the time the error happened, and this is the logging the level name, and this is actually logging in the message. So if we run this, and if I just take a look at the log file, this is actually a much better log file. We have the exact time this actually took place, and we have the error level, and it's even color coded, and we have the message at the end. So this is how you actually log information into in Python actually. So for example, you can actually use logging when you actually use the try and except block. So in try and except block, you are actually expecting something to get failed. So maybe I'll try something, and if that goes wrong, in the except block we can actually log some information. We can say logger, we can actually say logger dot whatever we want, and log that information into the file. So this is what logging is used for. I hope you understood what logging is and how to actually use it, and you can actually use it in a program of yours and try it. So that's it. So in this tutorial, I'll be talking about JSON data types in Python. So if you are actually if you have actually used APIs for getting information, for example getting cryptocurrency prices, or maybe stock market prices, or some kind of data, you might be able to know that most of those data come in JSON format. So we need to know how to actually work with JSON files. If you are into Python, if you are into working with different APIs, if you're trying machine learning, or yeah, it's cool. So let's see how to actually work with JSON files. So you can of course use a normal text file for storing and accessing data, but JSON is actually more efficient. So to work with JSON, you just need an inbuilt module called JSON. So we can say import JSON here, and this will actually import the JSON. It's an inbuilt module. You don't have to install anything externally. You just can use it. So let's see how to actually convert a dictionary into a JSON first. So I'll say my dictionary. So let's actually see how to work with dictionaries, or how to convert dictionaries to a JSON file. So we'll say my dictionary. I'll declare a variable here called my dictionary, and let's say that dictionary has a lot of, so in this dictionary we have some details of some people. So and it is actually a list of people, so we can see this. Inside this we have other dictionaries with key and values. So for example, we have the name of the person here, so we can say maybe Jack, and we have his, so we have to put a comma here, and we have to say his age is, it's probably 30. So we can actually say an age here, and then maybe his weight here. So yeah, so we can say his weight is 30. We need to say that inside a quote, and yeah, that's it. So now we have to create multiple dictionaries like this. So we'll just copy this and Control C and just paste this. So we have 3 people here, and at the end we need a comma to separate each items. So we'll actually change the name to Julie here, or July, or whatever it is. So we'll change her age to 25, and her weight is probably 60. Okay, so we need a comma here as well. So we have to change this name here, and we have to change this to maybe Peter, and we'll change this age to 22, and his weight is probably 50. And so yeah, we have details for 3 people here. Okay, let me just change this guy's weight here. So we'll change this to 70. Okay, so we have uh, a dictionary here with some lists, and inside that list we have some other dictionary objects. So to actually convert this into a JSON file, we can say we have the inbuilt JSON module imported, so we just have to use it now. So I'll say JSON string. So we have to actually convert this into a string and then write this to actually a file. So for converting this into a string, we'll use the JSON module. So we will say JSON dot. So we say JSON dot, and we have 2 methods, dumps and loads. So dumps actually take a JSON object and it can actually convert it into a string. So we'll say dumps, and so our JSON object is going to be my dictionary, and now we just have to write this into a file. So we'll open a file, we'll say with open, and we have to specify a file name. So I'll say file.json, and we have to open it in write mode since we actually want to write data into it or write information into it, and we have to give it a name. So we'll say file here, it can be whatever you want, and now we can say file dot write, and we should actually be writing this JSON string inside it. And now yeah, that should be it. So now if I run this program, it has been completed successfully. So we should actually have a file. So if you open this JSON file, you can see that this is poorly formatted. We have everything in a line, and this is not really good, because if you have a lot more data, this is going to be really bad and it's going to be very hard to read. So to make it easy or more readable, we have to actually add indentation, or we have to actually add some spaces. And for that, we can actually say we have to come here to json.dumps, and we have to specify an argument here called intent. Intent, and we have to specify how much intent we need. So if I just say 2 here, and let's rerun the program. If I check this, okay, so now this has been intended correctly. You can try other numbers, maybe 4, and we run this, let's see. And you can actually, yeah, this looks good as well. So you can actually try with different things, and take one that actually you really like, well formatted thing. So now we have a JSON file with some JSON data inside it. So we have seen how to actually write to a file, how to actually convert a JSON object to a string and write it to a file. Now let's see the reverse of it. I mean, how to actually read from a JSON file. Let's actually see how to do that. So we don't need this code now. So let's import JSON as usual, and now what we need to do is we need to open the same file. We'll say with open, and we need to specify the file name. So in our case it's file.json, and we need to open this in read mode, because we just don't need to actually write or do any modification to it. We just need to access the data. So we'll say as file, we are giving it a name, and now we'll say JSON object, and we'll say JSON obj. It's just a variable, so we'll say JSON dot loads, and this is actually going to load data from a JSON file. So we have to specify f or file dot read here. So we have to read from that file, and now if you just print out this JSON object, and if I run this program, you can see that it has been printed out, and we get all the information that was actually in the JSON file. So now to actually get a specific item, so say I want to get this name called Jack, so it is actually inside this dictionary called people. So let's access the individual element, or let's access that item called people, and then inside that we should get the first list. So this is actually a list here, so we need the first item inside. So I'll say item from the 0th index, and if I run this, okay, so now we got that. So it's another dictionary. So let's specify the key here, and we'll be able to get that item. So now if I run this, I get the name. So yeah, this is how we can actually access individual elements or specific elements from that JSON object. Hello guys, so in this tutorial I'll be talking about random module or random function in Python. So we have discussed about this in our beginners course, but that was too basic. Now we'll see how to actually do more things with random, and we'll actually make a small project using the random library. So random library is basically actually used to generate random values, or make random choices, or do things randomly. So to actually use random module, you actually have to import it. So I have to say import random, and we can actually do a lot with this. We can generate random values, we can generate values according to our needs randomly. Actually, even though it's actually a random library, you may think you can actually make some random strong passwords with it, but Python recommends that, or this module recommends that you shouldn't use random for cryptographic functions or generating strong passwords. They have separate modules for that, like the secret modules. So but still we can actually use this to make some random values. So to just make a random value, you have to say value is equal to random dot random. So this will actually basically create a value random dot random. Yeah. So this will actually create a random value between 0 and 1, but it will not be 0 or 1. For example, if I print this value and if I just run this program, you can see that it's a 0.99 number, and if I run it again, it will be 0.52 number. So this will never be 0 or 1, so it will be a number between 0 and 1. So that is how this thing works. So this is not really useful because just can generate only a random number between 1 and 0. So if you want to actually specify a starting and a stopping number, for example, you want a random number between 1 and 10. So for that you can say value is equal to random dot uniform and 1 and 10. So this will actually generate a random value between 1 and 10 if I run this, and it will be float here. So 1.29, if I rerun it, it is 8.44. Each time this will be a different value, but there are chances that you may actually encounter the same value twice. So now these are all float values. If you want an int value, for example, you can do that by saying value is equal to random dot rand int. This will actually generate a random integer value between two numbers that you specify. So I'll say 1 and 10 here. So it has generated 2, 5, 1, 6, 8, 7, 6. So yeah, it has started generating the same number. So yeah, you have a chance of getting the same number again in the random value. uh, so so now if you actually want to make a dice scenario, for example, in a dice you'll have a 0 to, okay, you'll have 1 to 6 here. So if you want to actually stimulate a dice here, you can just specify random from 1 to 6, and this will actually generate random values between 1 and 6. So now if you just want to stimulate a coin here, you can say 0 and 1. So this will actually generate either 1 or 0. So yeah, either heads or tails. So now let's discuss on how to actually uh, get a random value from a list. For example, I'll have a list here called greetings, and it will have some values like hi, hello, hey. So it just having three values here, or three items inside this list: hi, hello, and hey. So if you just want to get a random number or a random value out of it, I'll say random. I'll just declare the value variable here again, and I'll say random dot choice, and we'll say greetings here in this case, and we have to print value plus a name, maybe, for example, John. So this will actually select a random value from that list, and it will actually add the name with it. So let's run this. Okay, we need a space here, so yep, that should be enough. Now this says hi John, hi John, hi is again selected. Okay, hey, hello has been selected. So yeah, okay, so if you just want to select more than one random items inside this list or inside a list, you can use the dot choices method. So let's actually Now let's discuss on how to actually get more than one random choice from a list. So I'll declare a list here called colors, colors, and we'll set its value to red, green and blue, and yep. So now say for example we need random colors, so we need to actually more than one random colors from this list, so we can use the dot choices method, and you can actually say colors inside, and you also have a k method or a k argument that you can actually specify, indicating how many choices you actually want. So if you say 5 here and I print r here and I run the program, you get 5 different random choices. So yeah, 5 different things are selected, or colors are actually selected from this list randomly for 5 times, and it is actually printed as a list here. So now if you see that all of these colors are given equal weightage, so there is an equal chance for printing red, green, blue. So yeah, all of them have equal chances. And for example, if you want to actually make one thing more valuable, for example, if you want to make blue a more valuable color that can be found, or that a person can actually get randomly in a very less chance, you can use the weights argument. So you can actually specify weights here, and this should be a list. So since we have 3 items here, we should actually specify the weightage or the probability that for each colors to occur. So I'll say 100, 100 and 10. So in this case, blue has a very little chance compared to the other 2 colors. So blue has a very little chance compared to any other colors. So yeah, this numbers are totally random. You don't need to specify 100 here, but I just did it here. It can be anything, but what basically we are telling here is 100 or red and green has more chance than blue, so blue is rare. So now if I print this out, okay, the first list has been printed out, there is no blue inside. So if I rerun this, still no blue, rerun this, still no blue, rerun this, still no blue. Okay, yeah, fifth time we get a blue color, so which means blue is actually very rare and very hard to get. Now let's see how to actually shuffle items, or how to actually shuffle items inside a list. So I'll first generate a list here. So for example, say we have a deck of cards, so cards, 52 cards. So we want to actually generate numbers from 1 to 52 here. So I'll say range of 1 to 53. So yeah, the last element will not be printed, so we have to specify 53 here, and we have to convert this into a list so that it will be printed out as a list. And now if I print out deck and if I run the program, yeah, we actually get all the numbers from 1 to 52. So now if you want to actually shuffle this, we can actually say random dot shuffle, and we have to pass the list inside, so we'll say deck. So now if we just print deck out, so we are actually printing deck before shuffling and after shuffling. Let's see the difference. Okay, this is actually in the proper order, but this thing has been shuffled randomly. If I rerun this, you'll get a completely different order. This thing remains the same, but this thing has been shuffled. So if you rerun this again, you'll keep on getting different orders because they are randomly shuffled. So this is how you actually shuffle uh, different this is how you shuffle a list in Python or using the random module. So now say you actually have to get a random item from this list, so you just don't need that anymore. Okay, say you actually want to get a random numbers in this list that has 52 numbers. So you can use the choices method for sure, and you can get multiple random numbers. But if you do that, you may get same numbers twice um, in the same list. So that is actually not really good. So if you want completely unique random numbers, you have a method here. We can actually say s is equal to random dot sample, and we have to pass in that list, and we say k is equal to 5. K actually says how many numbers we want in total, how many random numbers we want in total. And if I print this out, it will be a list with 5 random numbers, and in that list it will not be repeated. No number will be repeated twice. So sample actually ensures that you get completely random numbers, and no number will be repeated twice in a while using a sample method. So that's everything about random module in Python. So now let's create a small Python project using the random library. So I have already put together a small project here. I'll explain it to you what it does and how it works here. So I have a list here. So let's take a look at this project. I found this project on a GitHub repository. Uh, this is actually a very simple Python project for demonstrating random library. I found this on GitHub. It's actually a very easy project. So what this does is this has so we have a lot of lists: first name, last name, street name, fake cities, states. So we have 5 lists here with dummy values, with a lot of dummy values inside. So with a lot of dummy values we have inside. So this will do is this will actually generate random people names, random city names, random country names, or random phone numbers using Python. So using the random library. So I already have some pre-lists here. So that has some first names, last names, street names, and some cities, and some country names or country codes actually. So for number in range 1 to 100, so we actually want to create 100 data here. 100 times we actually have to execute this code 100 times, which means we actually have to create, or we are actually wanting to create 100 data here, 100 different data here. So for the first name we'll select random dot choice. So we'll actually randomly select something from this list, and we'll do the same with the last name. So we'll actually select something from this list. It has a bunch of last names, and it'll actually randomly select from it, and then what it does is it will actually generate a random phone number. So this may change according to your country. So what it does here is it will actually first find a random number between 100 and 999, random integer numbers, and then add 555 to it in the middle, and then it will actually generate a random number between 1000 and 9999. So a demo data will be like a demo phone number will be like maybe 888 555 and then 1500. So yeah, this will be a random phone number generated by this function. So it will actually first fetch a integer number between 1 and 999, and then add 555. So 555 actually is default. So 555 will be there in all the phone numbers, and then it will actually generate some random numbers between 1000 and 9999. And for street numbers, it will actually make a random street number between 100 and 999. So something like maybe 890 or 110. And for street, it will actually select a random street using the dot choice method from the street name list, and it will do the same for the state, for the city as well, and then for the address, it will actually generate an address by combining the street name or the street number and then the street. These are all defined here, so it will actually combine the street number, street, and then it will actually add a st, I don't know what that is for, and then it will actually add a city, state, zip code, and it will actually print out all the above generated data in a particular format. So this address here is just to format it or to print it properly. And then for email, it will actually first dot lower. So yeah, from we have the first and last name generated here. So this program will actually use that first and last name and create a random email address, and it will actually add at boxmail.com at the end, and then it will actually print all the generated data. So if I just, I'll have this code, I'll just put this code, you can actually copy it, and if you run this program, you can see that it has actually generated 100 random numbers, I mean 100 data for different people here. So yeah, Steve Moore, and we have a number here, and we have his address here, and we have its email here. So yeah, you can actually play around with this random function and make something with it. So this is how you actually work with random function in Python. Hello everyone. So in this tutorial, we'll be discussing about decorators in Python. So decorator is actually a bit of an advanced concept, and it is actually a little bit more difficult to understand, but I'll try to simplify it as much as possible. So before we discuss about decorators, we need to actually understand uh, some concepts like first class functions and closures. So let us discuss a little bit about both these concepts before getting into decorators. So first class functions allow us to treat functions like any other objects. So we have some functions here, so they allow us to actually treat us like other objects. So we can actually pass a function to a variable, or we can actually give it as a argument inside a function. So we can actually give a function as an argument inside another function. So these are called first class functions. So basically they allow us to treat functions as any other normal object. And closures allow us to take advantage of the first class function and actually return an inner functions. So I have a few line of code here. So I have defined an outer function, and inside that we have a message variable, and it is set to high here, and we have a inner function here, and basically what it does is it will actually print out this message. So this inner function has actually got access to this message variable which is in the outer function. So and what it basically does, it actually prints it. So when we actually execute the inner function here at the end, so we actually return the inner function here. So now if I just print, or if I just execute the outer function, and if I just run the program, what happens is it prints high, or in other words, the inner function gets executed. So that is what is happening here. So now let's actually return the value of this inner function without actually executing it. So to do that, just have to remove this parenthesis here, and now the value will be returned and it will not be executed. So if I just run the program, you can see that nothing has been printed because we haven't executed it. It only just returns the value. So now we can actually pass this to a variable. So I say my function, or whatever you want to call it, my function. And now to actually execute this, we can say my function of. And now if I run this program, you can see that high has been executed. So this is what a closure is. A closure actually remembers our variable or the value of our variable even after executing the outer function. Okay, now let's execute this multiple times. So we'll say my function, let's execute this 3 times maybe, and then uh, let's execute this 3 times, and if I run this, you can see that it has been executed thrice. So this is what a closure is. A closure remembers our variable, or actually it remembers our value inside the variable even after executing this outer function. So this is what a closure is. So now we can actually just go here and just remove this message variable, and instead of setting our variable inside this, we can actually directly pass. Okay, we can just remove this hi message, and we can actually say msg here, and we can actually pass this here. So yeah, and now if we can actually create 2 functions. So now we have actually removed this hi from here, and we can actually now pass this. So let's just remove all this, and we'll create 2 variables here called hi function and by function, and inside this we'll say hi, and this will be by. So now if we just execute this hi function and by function, and if we run this, you can see that hi and by has been executed. So this is just what closure is. So I think you actually got a basic idea on what closure actually is. So yeah, the definition for closure is simply they are just inner function that can actually access the variable in from the main function, and then can actually print out things or do things according to that. So yeah, they are just inner functions. So I now think that you actually got a basic idea on what closure is. So let's discuss what a decorator is. So a decorator in Python is a function that takes another function as its argument, adds some extra functionality to that function, and then returns yet another function. Decorators can be extremely useful, and they allow you to extend the function without actually modifying the source code of the original function. So the source code will remain the same, but you can actually modify the functionality of that function. So let me just copy paste some code. And so if you see, I have a new function here, and it is exactly similar to the older function that we actually used to discuss closures. So if you let's look at here, both of them are same except the names have actually changed. So we don't need this, we have to remove this, we don't need this as well. So instead of actually taking a variable as a parameter, our function or our decorator actually takes another function as its parameter. So in our closure, it was actually taking a variable as a parameter, but here it will actually take another function as its parameter, or as an argument. So now instead of this message here, let's pass a function inside this. So I'll just remove this message, and I'll say original function, or whatever you want to call it. And instead of printing the message, let's just execute that original function inside this. And so now let me just paste some code here. So I have some code here. It's basically a display function. What it does is it just prints out display worked message here. So yeah, this is a simple display function that prints something. So here it prints display works or display worked. So now we have declared a decorator display variable here, and we say decorator function and pass in the display function inside it, because this thing takes a function as a argument or as a parameter here. So we'll pass the display function here, and let's just return. Okay, let's return the original function here. So after it runs, it actually returns the value. So okay, so let me tell you what it is happening here. So we are actually setting, we have two functions here first of all, and this display function simply prints display worked. So its job is to just print this statement. So now we say decorator display, this is just a variable, and we are executing our first function. So if we just look at this function here, we can see that it actually takes an argument. It actually takes a function as an argument. So here we are passing the display function as an argument for this function, and then it actually when we actually execute this decorator display function, it actually executes the wrapper function which is inside this decorator function. And if the wrapper function get executed, it executes the original function and returns the value for the original function, which in this case is the display function. So basically the display function is getting executed here. So this function takes another function as its parameter. So this is a decorator. So if we just run this program, you can see that display worked has been printed. So if I just rerun this, we can see that display worked has been printed. So if we just run this program, we can see that display worked has been printed. So that is how it actually works. So basically we are actually executing this function with another function as its argument. So when it actually goes here, it actually executes this inner function, and then it actually goes here, and so when we have to execute this wrapper function and return its value, so the wrapper function just executes the original function or the function that we gave as a parameter here, which is the display function, and it gets executed and the value get returned. So that is what is happening here. This is actually a very simple or very simplified form of a decorator, the most simple form of a decorator if you want to call it that way. Now that we have a basic idea on how this wrapper function works, let's see what or why we use this, or why do we use such a difficult thing. So wrapper functions, it lets us add functionality to our existing functions without actually modifying our original function. For example, in this case, the display function, without modifying this display function, we can actually add functionalities to this, or we can actually execute or do things before or after executing this function. So for example, say I want to print something before executing this display function, I can actually say, for example, I'll come here and I'll just say print, and we are going to use the format strings, and I'll say wrapper function executed this before. We will put a curly braces here, and then we'll just get the function name using the original function dot name method. So this is just to get the name of the function. So in this case, it will actually have to display here. So now if I just run this program, let's see what happens. So we can see that wrapper function executed this before the display function. So now we actually didn't modify any source code for this function, but we still executed this. We actually modified this, and we were able to do many things without actually modifying the original source code of this function. So that is why we actually use decorators. Okay, so now we actually have discussed some basics of so now we have actually discussed some basic things for decorators, but this is not the actual syntax for decorators in Python. So I just did this to explain things to you. So now to actually this is actually the real syntax. So we say at decorator function, so we are actually adding this functionality to our display function by saying at decorator function. So this is the same thing as this now, but since we have added it, we just need to execute it by simply saying display. And now if we just run this, you can see, So this is actually equal to saying that we want our display function to be wrapped in, or we want our original function. In this case it's display function, but we want our original function to be wrapped in this decorated function. So yeah, it's basically the same thing. So if I just say, so after adding this thing, or after adding this decorator, we just simply need to say display and execute this function. This functionality has been added here now, so we don't have to use that old syntax. This is the real syntax for decorator. So now if I just simply execute this, we get the same result as before. So this is the real syntax for decorators. So now we are actually going to use this syntax from now on, as this is actually much easier. We are basically saying that we need to add the functionality of this to this as well. So it is also equal to saying that display is equal to decorator function of display. So both these commands here do the same thing. So we don't need this anymore. So we are just removing this. We'll simply use this display itself. So we are just adding this here. So now we have a small problem here. So this wouldn't actually work if we actually pass in some arguments. So for example, I'm actually declaring a function. I have pasted 2 lines of code here. So this is actually another function called display info. So this takes 2 parameters, name and age, and it actually prints it out. So that's what it does. So let's comment this thing out, and now if I say display info, and I'll give the name as Jack and his age as 30, and if I run the program, it works. So yeah, the infos are Jack and 30, so it prints it like this. So now if I just add this decorator by saying at decorator function, if I just simply add this, and if I try this again, we get an error here. It's an expected error. We get it takes no positional argument, but 2 were given, because if you look here, it takes a function as an argument, and we already gave that, but it doesn't take any arguments here. So now to solve this, so if you just check the error message here, it actually says type error, wrap function takes 0 positional arguments, but 2 were given. So wrap function is not able to accept any arguments. So in order to solve this, we actually need to do something. So we have to say here star args and star star quarks. So basically in Python, these two. So now by adding this args and quarks argument, now you can actually add any number of arguments inside this function. So now this prevents errors. So you also have to add this method, or add this args and quarks inside this original function as well. And you only need 1 star here for args and 2 star for quarks. So now if we just print out, or if we just execute both this display and display info function, and if we run the program, we can see that both of them got executed and we have no more errors here. So